Hi everyone. Today we will discuss about the calculations in UV visible spectroscopy. So let us start with one of the working example 1. Calculate the absorbance of a sample showing 40% of the transmittance. So here whatever the data given is the percentage transmittance is given as 40% and we have to calculate the absorbance of the sample. So this is a simple problem and here we have to convert the transmittance into absorbance. So let us see the solution to this working example 1. First of all, let us see what is transmittance. Suppose we take a sample and we are going to irradiate the sample with a UV visible source. Then the light is going to be passed through the sample and sample will absorb some of the radiation. So suppose we are sending the radiation with intensity I0 and it will come out of the sample as IT, that is the intensity of the transmitted radiation. Then the transmittance is nothing but is a simple ratio of the IT by I0. That is intensity of the transmitted light by the intensity of the incident light. So this is the transmittance. Then what is the absorbance? Transmittance and absorbance are quite reciprocal, but they are not directly reciprocal. So absorbance A is equal to log of I0 by IT, where I0 is the intensity of the incident radiation and IT is the intensity of the transmitted radiation. So here you can observe that it is a logarithm of the ratio which is nothing but the reverse of the transmittance. So the transmittance is IT by I0 whereas absorbance is log of I0 by IT. Now we can write the absorbance A is equal to log of 1 by T because the ratio is going to be reversed. Now this is nothing but minus log T. So in this way the absorbance is equal to minus log T. But here the transmittance is given in terms of percentage. Then we can again use another equation A is equal to 2 minus log percentage T, where we are going to use the percentage transmittance, and since the log 100 is nothing but 2, so we can write the 2 minus log percentage T. So now we can use this equation in order to calculate the absorbance of the given sample. So here absorbance A is equal to 2 minus log percentage T. So here the percentage transmittance is given as 40%. So by substituting this equation it is 2 minus log 40. So log 40 value will gives as 1.6. So it will be 2 minus 1.6 which gives the 0.4. So if a sample is having 40% transmittance, the absorbance will be 0.4. And we should remember here that the transmittance and absorbance, even they are reciprocal, they are not directly reciprocal. The absorbance A is equal to log of 1 by T. Otherwise absorbance A is equal to 2 minus log percentage T. Now let us go with the working example 2. Calculate the amount of the drag present in a sample per 100 ml if that has shown absorbance of 0.742 in UV visible spectrophotometer using a cell of 1 cm at 280 nanometers. So the molar absorptivity of the drug is 1860 liter mole inverse centimeter inverse and molecular weight is 153. So let us see the data given. Here the absorbance A is given as 0.742 and there will be no units for the absorbance because absorbance is a ratio. Epsilon, the molar absorptivity is given as 1860 liter mole inverse centimeter inverse. And third one, the molecular weight is given as 153, path length is given as 1 centimeter, and here we have to calculate the weight of the drug present in 100 ml of the solution. So let us go with the solution to this working example 2. So which equation we can use? We know the Beer-Lambert law which gives one of the equation A is equal to epsilon BC, where A is the absorbance and epsilon is the molar absorptivity, B is the path length and C is the concentration. Now by substituting in this equation 0.742 is equal to 1860 because epsilon molar absorptivity is given as 1860 into 1 because path length of the cell is 1 centimeter. So into 1 into C, where C is the concentration. Now rearranging this equation we will get C, the concentration is equal to 0.742 by 1860. So by calculating this we will get a value of 3.99 into 10 to the power of minus 4. So this 3.99 can also approximately we can write as 4 into 10 to the power of minus 4. And what are the units? Units are the moles per liter, or simply it is a molar concentration. So the concentration of the sample is 4 into 10 to the power of minus 4 molar or moles per liter. But here we have to calculate the concentration in terms of gram per 100 ml. So this is not the end of this solution. So now we have to convert this moles per liter into the gram per 100 ml. In order to do that, we should know what is the definition of the molarity. When the concentration is measured in the molarity, then concentration is equal to weight by molecular weight. Weight by molecular weight is nothing but the number of moles of the sample. So weight by molecular weight whole by 1 liter of the solution. By using this equation, now we can calculate what is the weight of the drug per 100 ml of the solution. So now we got the concentration as 4 into 10 to the minus 4 moles per liter, which is equal to weight, which is unknown, by molecular weight is given as 153 whole by the liter can be written as 1000 ml. From this we can calculate what is the weight of the drug per 100 ml. Now weight by 100 ml is equal to, because 1000 ml can be written as 100 into 10. So 10 will comes here. So 4 into 10 to the minus 4 into 10 into 153. Here on calculation we will get it as 0.612 grams. Now the sample is having 0.612 grams of the drug per each 100 ml of the solution. Now let us go with another example, working example 3. A drug with absorptivity of 13.42 deciliter gram inverse centimeter inverse has shown absorbance of 0.476 in a cuvette of 2 centimeter at 247 nanometers. Calculate the following if the molecular weight is 112. So what we have to calculate is the first one, molar absorptivity, and second is the concentration. So again here let us see what is the data given. Here absorbance is given as 0.476 and absorptivity small a is given as 13.42 deciliter gram inverse centimeter inverse. Molecular weight is given as 112, and here the cuvette size is 2 centimeter, that means the path length is 2 centimeters. And now we have to calculate the molar absorptivity as well as the concentration of the drug in the solution. And here you can observe the term absorptivity small a, where the units are given as deciliter gram inverse centimeter inverse. That means here these units indicate that the concentration is expressed in terms of percentage weight by volume. Otherwise the concentration is given in terms of grams per 100 ml. So from this absorptivity we have to calculate the molar absorptivity as well as concentration of the drug in the given sample. Now let us see the solution to this working example 3. Again, which equation we have to use? We can use the same equation, A is equal to ABC, where here small a is the absorptivity, and by substituting the values in this equation, 0.476, because absorbance is given as 0.476, is equal to 13.42, where absorptivity is given as 13.42 into 2, because the path length is 2, multiplied by concentration, which we have to calculate. So now rearranging this equation, concentration is equal to 0.476 by 13.42 into 2. On solving this we will get 0.0177. Then what are the units? Since the absorptivity is expressed in the units of deciliter gram inverse centimeter inverse, the concentration should be expressed in terms of percentage weight by volume or gram per 100 ml. So here the units of this concentration is gram per 100 ml. Now the concentration of the drug in the sample is 0.0177 gram per 100 ml. This can also be written as 17.7 milligram per 100 ml. Now let us calculate the molar absorptivity. We have given with the A value, but we can also have another type of absorptivity, the epsilon, which is called as molar absorptivity. So A is simply absorptivity and epsilon is the molar absorptivity. We can easily differentiate these by the units given in the data. For example, absorptivity is measured in terms of deciliter gram inverse centimeter inverse, whereas molar absorptivity is measured in terms of liter mole inverse centimeter inverse. And sometimes the small a can also be used to indicate the molar absorptivity, where the units will be liter mole inverse centimeter inverse. But for a strict differentiation, we have to use the small a for the concentration, which is measured in percentage weight by volume or weight by liters, and epsilon when it is measured in the moles per liters. The absorptivity can be used when our concentration is measured in grams per 100 ml or grams per liter. So whenever molecular weight is not involved, we can simply use the absorptivity A. But whenever the molecular weight is involved and we are going to apply the moles per liter, then we have to use the epsilon as the molar absorptivity. So here the absorptivity having the units deciliter, gram inverse, centimeter inverse indicates that the concentration is measured in grams per 100 ml, whereas molar absorptivity, which is measured in the liter, mole inverse, centimeter inverse, indicates that the concentration is expressed in the moles per liter. Now what is the relation between the absorptivity and molar absorptivity? Now the epsilon can be written as epsilon is equal to A into 10 into molecular weight, where A is the absorptivity. So this equation is going to be valid when the concentration is measured in grams per 100 ml. But when the concentration is measured in grams per liter, then the term 10 is not observed, and then epsilon is simply the A into molecular weight. Now here substituting the values, it will be 13.42 into 10 into 112, so which on calculation gives 15,030.4 liter mole inverse centimeter inverse. So these are the few of the examples of the calculations involved in the UV visible spectroscopy by using the Beer-Lambert law. So that's for today. If you like this video, please subscribe to our channel and share this video with your friends. Post your comments in the comment box. Thank you for watching this video.